This video is going to walk you through the relationship between an equilateral triangle and an equiangular triangle, and then also has a few examples where you're going to apply the relationships found in these two types of triangles. So I'd like you to recall that an equilateral triangle is a triangle where there are three congruent sides, and an equiangular triangle is a triangle with three congruent angles. And so what we're going to go through right now is an informal proof showing that an equilateral triangle is also an equiangular triangle. So we have triangle GFH, and we see that segment GF and segment GH are congruent. So marking that on the picture, segment GF and segment GH congruent, using the isosceles triangle theorem, we know that angle F and angle H must be congruent because they're the two sides opposite those angles are congruent. However, we also see that segment GH and segment HF are congruent. So marking segment GH and segment HF congruent, we know that now angle G and angle F are going to be congruent. Finally, segment HF and segment GF are congruent, so marking those congruent, segment HF and segment GF, we now know that angle H and angle G are congruent. Therefore, we see that all three angles are congruent to one another and all three sides are congruent to one another, so an equilateral triangle is going to be the same as an equiangular triangle. So anytime you know that all three sides are the same, all three angles are the same. Now, looking at three examples where this concept is applied, we have triangle DEF, and we see that DF, DE, and FE, those three sides are congruent. So therefore, using the relationship, we know that angle F, angle D, and angle E are all 60 degrees. So in order to solve for the variable x, since angle F is 60 degrees, we can take the expression 6x and set that equal to 60 degrees. And if we divide by 6, x is equal to 10. The sixth example, we have triangle GJH. And we see that angle G, angle J, and angle H are all congruent. So we then know that all the sides are congruent. Now, using this relationship, we know that 6x minus 5 for segment GJ and segment GH represented by the expression 5x are going to be equal. And so if we solve this equation by subtracting 6x, we have negative 5 equals negative 1x. And if we divide by negative 1, we see that x is equal to 5. Now, in order to find the length of JH, there's no expression used to represent this side. However, if we substitute in to either of the two expressions, 6 times 5 minus 5, that gives us 30 minus 5, which is 25. And if we substitute into the expression for segment GH, 5x, so 5 times 5, we see that is also 25. And because it is an equiangular and also equilateral triangle, the length of GH would then be 25. An extension of this would then be to find the perimeter which would have a total distance around the triangle of 75 units. Our seventh example asks us to find the values of x and y. Now, based off the markings on our triangle, we see that we have two congruent sides, and so using the isosceles triangle theorem, if the sides are congruent, that means the angles across from them also must be congruent. So we can set up an equation, 3x minus 11 equals 2x plus 11. Solving this equation, if we subtract 2x from both sides, we end up with x minus 11 equals 11. And adding 11 to both sides, we see that x is equal to the value of 22. Now, in order to find the value of y, there is only one expression, so we need to use the answer for the variable x in order to assist in solving for y. If we substitute 22 back into our expressions, 2 times 22 plus 11, that gives us 44 plus 11, that gives us an angle measure of 55 degrees. Additionally, if we do 3 times 22 minus 11, that's 66 minus 11, that gives us an angle measure of 55 degrees. We can then use the idea that all three angles of a triangle add up to 180 degrees, so we can take 55, 55, and 2y to set up an equation. So 55 plus 55 plus 2y, and set that equal to 180. Combining like terms, 55 plus 55 is 110, so 110 plus 2y equals 180. If we subtract 110, 2y is equal to 70. Dividing by 2, y is equal to 35. And substituting back in, 2 times 35 gives us an angle measure of 70 degrees. And just checking, 55 plus 55 is 110, plus 70 is 180 degrees. I would now like you to go through and complete questions 9 through 16 in your note packet and check your answers with the answer key posted on the class website.